Good afternoon. My name is Ian Ryan. I'm going to be giving a TED Talk on cement and the environment. So just an agenda where we're going to be going through. We're going to talk a little bit about the cement making process and the energy and fossil fuels that go into that, the environmental impacts of the cement making process, and some alternatives to cement and probably some solutions. So just a brief overview. In 2012, the global consumption of cement was 3,736 million tons. The rising rate of consumption is roughly 5% annually. That's because of a rising population throughout the world. We need more infrastructure and buildings. China accounts for nearly 60% of the global cement consumption. That goes back to their population, and they're leading the production industry. Cement is composed primarily of limestone combined with other materials through calcification, which we'll be going through later. Important thing to keep in mind when I'll be going through this is cement is a measure of economic growth for a nation. More cement means more buildings, more infrastructure, and that reflects economic growth. If a company's doing well, they're going to need more businesses and jobs and homes. So what is it used for? Primary use, obviously construction, mostly. Basically every building structure today uses cement as a base layer. That's primarily for insulation. It's a great insulator and it's relatively cheap to make. Obviously highways and roads use a ton of cement. Through solidification and stabilization, it can actually take chemicals out of a contaminated area. By adding cement, the materials kind of gravitate toward the cement and it hardens and takes them out of the soil. So that's also kind of a neat alternative. So first, before we can talk about anything else, I think it's important that we get into how cement is actually made. This is a brief little video, showing the cement making process. I think I can actually just talk about it. The stone is reduced to 5-inch pebble-sized rocks, and then further 3 to 4-inch pebbles by crushers after it's taken out of the quarry. Then the raw materials, mostly limestones, shell, clay, slate, are ground into a fine powder and blended. Then the burning, it goes through a process called calcification through a furnace. That burning changes the raw mix into cement clinker through some chemical reactions. And then the clinker is added with gypsum. And it's ground into Portland cement, and then finally it's packaged and shipped. Alright, so calcination. This is probably the most important part of the cement making process because it's where the chemical reaction occurs that turns it into Portland cement. So it occurs when the limestone, which is a calcium carbonate, is heated, breaking down into calcium oxide and CO2. So calcination is carried out when the furnaces require fossil fuels to heat and maintain that temperature. So obviously through this process, just through the chemical process, it releases a lot of CO2 into the atmosphere. And then when you add the fuel required to heat that furnace, mostly the fuels are coal and natural gas, which obviously release a lot of CO2 when they're burned. Only 56% of the heat supplied to a kiln is used for calcination, which obviously means 46 is lost due to inefficiency. So this is a very heat-intensive process, and not a lot of the energy used actually goes into it. A lot of it is lost. So there's a lot of room for improvements of this process to make it more energy efficient. Here is a picture of the furnace commonly used in the cement making process. That's a thermal picture, so you can see that it's very hot. And just a brief kind of picture, The clay goes in, it's heated, like blasted with a lot of heat, it rotates, and through calcination, the chemical process along with the heat turns it into clinker. So, like, as you can see through the cement making process, it's very energy intensive. It's actually the most energy intensive of all manufacturing industries. That includes like making metals, other building materials, lumber, all of that. The US consumes 300 million tons of cement per year. That's more than a ton per person. So obviously we make a ton of this each year. And it accounts for 5% of the world's energy consumption. So what that means is, like, obviously, this is a very important part of energy consumption that's often overlooked. And another important thing is 1 ton of cement produces 1 ton of CO2 into the atmosphere. So this is actually, it's very inefficient and it's very harmful to the environment. So some energy used through this chart. I don't know if you'll be able to see it through the video. So I'll just talk about some things. Basically, quarrying, getting the stone from the actual like environment, it really doesn't require that much energy, only about 3% through the entire process. What the most energy intensive is the kiln and fuels. That accounts for 74% of all the energy and over 80% of the entire CO2 emissions are just from using the kiln and the fuels involved for that, and the chemical reactions. So the kiln, fuels used, on-site energy, 74%, CO2 emissions, 36.8%, and that is 10 to the 6 tons of CO2. And just through the chemical reactions, that emits 46.3% of like all CO2 during the process. So through calcification and heating the kiln, that requires 1400 degrees Celsius. So that's incredibly high energy, incredibly high emission process, especially when that's being produced at the rate it is, and it's only going to get bigger. Producing 1 ton of cement requires 4.7 billion British thermal units of energy, which is equivalent to about 400 pounds of coal for just 1 ton of cement. So you can imagine, very harmful process. Indirect emissions are produced by burning fossil fuels in heat kiln. I went over that. And so energy used to power additional plant machinery accounts for the 10%. 50% is from all the CO2. Another 40% is from heating in the kiln. And then the rest is just through like electricity used to power other aspects of the plant. So this diagram shows the type of fuels used for heating the kiln. And as you can see, 53% of the fuel used to heat a kiln comes from coal. And the other big ones is petroleum and electricity. So as you can tell, a lot of fossil fuels are going into heating the kiln. So what this means for the environment, the entire cement production process kind of has a few positive and negative impacts on the environment. For the human environment, obviously it increased goods and services, cement, like landscape, cement production, and it is used for a lot of other things. Promotes employment, opportunities, income, and wealth. Some negatives is it's damage to cultural sites where they blow up the quarries. Some impacts for the natural environment, obviously the removal and transfer of large amounts of rock and soil from the quarry, and I'll show a picture of that later. Damage to underground and surface drainage. When you take anything out of the earth, There's going to be like chemicals and soil that wasn't originally on the top, and that's going to get into the environment and cause some damages. The use of stream banks and shoreline for waste disposal. Obviously the runoff from where they produce the cement is going to be, like when it rains, it's inevitably going to drain to somewhere. For land, like every time you destroy a part of land, there's going to be reduced populations of wildlife. Increased wildlife mortality from road traffic and surface disturbance. That's not really a big issue. I mean, obviously animals are going to run out on roads. For water, stream siltation and contamination from soil erosion, kind of talked on that. Obviously contamination of surface and groundwaters from the runoff from the plant. Here, I'm not sure if you'll be able to get a good image, but it's just kind of a pretty big picture of a stone quarry where they blast the limestone. And this is like a full-size mining truck at the bottom. It's very small, and as you can tell, it's a huge area that they blast away. So it's pretty damaging to the environment. Some more some data. It's the third largest industrial process of CO2 emissions. So you got to figure if the global consumption of cement is 3,736 million tons annually, and producing 1 ton of cement emits 1 ton of carbon dioxide into the atmosphere. That means that the global cement consumption emits 3.47 billion tons of CO2 annually. Roughly 10% of annual CO2 emissions come from just the cement making process. So that's a pretty big part of where all the CO2 comes from. So yeah. So what can be done? We can make the cement making process more energy efficient. We can use alternative fuel sources to use in the manufacturing process, deviate away from coal and petroleum. We can use alternative building materials in place of concrete, and recycle old cement from buildings and infrastructure no longer in use. And we're going to touch on each of those parts now. So making cement more efficiently. This basically goes into more advanced techniques and machinery and equipment used in the cement making process. If you produce the blending, if you make the blending more efficiently, you can make reduce energy consumption by 5% by using a more efficient blender and making the process go faster. Using rolling grinders instead of ball grinders reduces energy use by 50% for the grinding process. So that basically just involves cement making companies investing in that new type of machinery. There's also a process of recirculating the gases burned in the kiln. Can increase energy efficiency by 10%. So all the fuel that wasn't used can sometimes get recycled back, making it more efficient. Obviously more efficient transportation vehicles for bringing the hard stone to the quarry, and also shipping the packaged cement once it's done. So some alternatives to cement. There's fly ash. This is like the fine particles filtered out of the combustion gases of coal burning electricity plants. So you can use the fly ash that's been filtered out from coal burning electricity plants. And the US produces roughly 7 million tons of fly ash every year. And if the US produces 300 million tons of cement, this could put a pretty big dent in our consumption. And most of it's stored or disposed in landfills. A company called Ceratec is using 95% fly ash and 5% liquid ingredients to create cement. And what's kind of neat about this is it requires no heating. So it's considered carbon neutral. So it totally erases the kiln out of the cement making process. So that reduces the chemical